Hello, hi guys, welcome to Learning and Living channel. I hope you are all doing good. And in this topic video, we are going to learn about
Operating system, but by using a CPU restaurant. What is, let us understand a few things about CPU restaurant. A CPU restaurant uh, used to get only few customers initially, but slowly it has gone up to 100 customers every day. And five delivery partners and customers come and wait for the tables to occupy for tea and for snacks and all. And suddenly, on one fine morning, when the restaurants open at 9 a.m., the, the there are too many customers and there is complete chaos in the restaurant. So what does the owner does? The owner hires a restaurant manager so that he can manage the the customers, the deliveries, the tables, as well as the kitchen staff to make sure uh, that the orders and the recipes are prepared fastly. So the owner hires a restaurant manager. Here the restaurant manager, similarly in our computer, we have operating system. An operating system is a software. But what is software? Software contains a set of programs. But what is a program? Program contains few lines of code. These lines of code contain instructions. Few lines of code is called as a program, and these instructions uh, are used in for a hardware. But what is a hardware? Hardware is a physical device. In brief, to understand, a software is a set of programs which has instructions and which tells the hardware to get the resources. In brief, we can understand that a software operating system is an interface between the user as well as the hardware. As like a restaurant manager, an operating system is an interface between the user and the hardware. I hope you understood. So, this kitchen staffs contain a recipe book, like whatever the order given by the customer. mm, to prepare that order, the kitchen staff contains the recipe. This recipe is our program is, as we already discussed, program is a set of instructions. Like a recipe is a set of steps. So now what we understood what is an operating system. It is an interface between the user and our hardware, like a restaurant manager, between the customers and the kitchen staff. And we understood about a program. Program is a set of instructions which is stored on the hard disk. Like a recipe contains a set of steps to prepare that particular recipe. Now let us understand about a process control block. When a customer a orders for a food, orders the what does our manager do? Our manager takes note of the recipe, takes note of the menu, and then give it to the kitchen. But how he manages a notebook so that he can note down what are all the required food item, the customer name, and the other details. Similarly, a process control block uh, uh, is like a notebook which the operating system maintains to store the process ID, CPU registers, the estimated time, and everything. This is called as a process block. Now, what does our restaurant manager collect here? Our restaurant manager collects the menu. That is, he collects the menu and give it to the kitchen. Similarly, when this recipe is given to the kitchen, this recipe is under execution. That is the program, the recipe, whatever is given by the customer is being prepared. This is called as the process. Similarly, in our language, a program which is under execution is called as a process. For this process, we have different process states. What do we have? Process states. Whatever the process that has been started in the kitchen, it continues in various processes. Like uh, it is a new dish. So new, it undergoes new state. It is under ready state if the to be cooked, and then we have waiting or new state, ready state, running, running, running state. That is the restaurant. The chef takes it and starts to collect the ingredients and then waits. He puts, if for example our food item is pizza, he takes all the ingredients and then waits to put it in the oven and waits until it is cooked. And after taking out it, he makes add some toppings and then mm, give it back to the customer. This whole process in our language is called as process state. I hope you understood. Now let us uh, know about CPU scheduling. S- Im- like imagine uh, there are many food orders that are taken by the restaurant manager. Uh, but there, as we already discussed, there are almost 100 customers who have been coming. Some for tea, some for breakfast, and some for orders. So, who has to be prioritized? The one first such approach is first come first serve. Whoever comes first uh, is served first. This is called as first come first serve. But we also have another method, like the tea can be prepared fast, so it takes only 10 minutes, while break first takes around 30 minutes for dosa or kind of another dishes. So the shortest job is given priority first, that is shortest job first. And then we have priority. If we in these customers we have a child, a doctor, or a software engineer. Sometimes a child has to be preferred if any requirement comes. So we have another CPU scheduling. The CPU is nothing but our kitchen staff. So this is called as priority. Or then we have another way as round robin. What do we mean by round robin? Suppose we have 4 chefs and every order, or as we got 3 orders, every order gets 5 minutes. Every order gets 5 minutes. If unfinished, the next order starts. Every dish that we are preparing gets equal time so that nothing gets delayed. This is called as round robin. Now, let us understand about critical section. What is a critical section? Generally, critical section means imagine there is only salt one salt container. Every chef needs the salt, and we have 4 chefs, and every chef needs a needs solved. This is called as critical section. How can this critical section be solved? We can solve in this. We again have race condition. What is meant by race condition? When these four chefs fight for the same salt, then a race condition might occur. Then we have shared resource. Instead of fighting, we whenever one chef is using, the other should wait. This is called as shared resource. Until now, we have understood about operating system, program, process control block, process, process states, new, ready, running, waiting, and terminated, and then about CPU scheduling, FCFS, SGF, priority, round robin, critical section, uh, race condition, and then about shared resource. This is all about the main important topics, and also we have something called as semaphore. What is semaphore? When a sorry, when 100 customers arrive and we have only 110 tables available. These 100 chairs can be occupied and only 10 are left. These counted to be calculated. This count has to be calculated, right? This is counted by a data structure called as semaphore. And now let us understand what is deadlock. Deadlock is a condition where chef A, we already discussed about one salt container. Similarly, when chef A wants salt and has salt but needs pepper, while chef B has pepper but needs salt, but neither of them gives up what they have. Both wait forever, so no food gets cooked. This condition is called as deadlock. I hope you understood. So just let us get what are the definitions of the whatever we have learned. So operating system is a interface between the user and the hard disk. A program is a set of instructions in the hard disk is called as a program. A process control block is like uh, it stores the OS stores information about process ID, state, program counter, and CPU registers. This is called as a process control block. Like our manager notes up all the information. Now process a program under execution is called as a process. And process states, mainly process states are of 5 types: new, ready, running, waiting, terminated, and CPU scheduling. CPU scheduling is a process of selecting one process from DQ and allocating CPU to it is called as CPU scheduling. Ah, and in CPU scheduling, we have 4 different ways: FCFS, first comes first serve, short job first, and priority based on the priority, and round robin. This is important. Round robin is like every task is given equal time, so that everything gets time and there is no waiting time. Then we understood about a critical section. Critical section is a part of a program where the shared resources are accesses and must be protected to preserve the data inconsistencies is called as critical section. In brief, critical section uh, to is a part of code so that the shared resources must be protected. Like in critical section, we saw about the salt container. This all come under critical section, that is race condition and shared resource. And then we understood about semaphore. Semaphore is a data, is hmm, the data structure which keeps the count of the resources. And then we understood about the deadlock. It's a condition where uh, both of them fight for each other and both of them do not leave what they have. So we can you can just go through here the same definitions whatever we have discussed by comparing it with the CPU restaurant, and then we discuss about program, that is a recipe, and then okay, we RAM is nothing but a mm, kitchen counter is called as a RAM. For example, we take the ingredients from the storeroom and get it to the kitchen counter. That is called as RAM. Like whatever is going to be used in the orders mentioned, we put it on our counter. Mm, That is a primary memory. Like for temporary store programs, we use RAM. And then we understood about a process. A program that is currently running is called as a process, and then operating system control block. It's like a manager's order notebook. It is a data structure which maintains the OS. And then this process contains different process states as we discussed, that is new, ready, running, waiting. Uh, you can also go through these definitions. And then we understood about CPU scheduling, decides which order the chef should prepare next. That is called as CPU scheduling. And then thread is the smallest unit of CPU execution within a small process. And for example, multiple chefs work on different parts of the same order. It is called as a thread. And multiple threading is like one large order is handled simultaneously by multiple chefs without wasting time is called as multiple threading. Execution of multiple threads within a process concurrently is called as multiple threading. And then we understood about critical section, that is about the salt container, race condition, mutual exclusion, progress, and bounded waiting. You can just check out the definitions and about whatever we have discussed here. And then a semaphore is like a counter showing how many tables are available, and the synchronization mechanism using an integer variable. And also we have understood about deadlock. Deadlock is a situation where two or more processes wait indefinitely for resources, like a salt and a pepper. And then mutex. Mutex is a locking mechanism that allows only one thread to process a shared resource at a time. For example, to manage a room, only one chef, the like uh, chefs is called a sous chef. There will be a highest chef among this is a sous chef who has only access to the shared resource is called as a mutex. I hope you understood. Thank you for watching. If the video is useful, do like, share, and subscribe. Happy learning!